welcome to the next session, which is the ninth chapter of the exponents and logarithms, which is extension or extended calculus. Okay, so I'm sharing my screen. Okay, for the student, I'm sharing my screen. Just give me 1 minute. Yeah, now I shared my screen. Is it clear? Is it okay? So I think my screen is a little bit clear than my previous. It is a different laptop. Okay, my camera could might be clear too. So here we are in the ninth chapter. So what is the chapter name? Extending calculus. So far calculus has been developed algebraic functions. Okay, algebraic function just like 2x, x square, x cube, e power x, on all basic functions are there. So now, so it is a chapter 9a, exponential function with base e. Exponential function with base e. So what is the derivative of e power x? Derivative of e power x. See, we have to see two. We have two functions. One is y is equals to e power x. Another one is y is equals to log x. Okay. So I'm giving the derivatives. dy by dx is equals to e power x only. But here dy by dx is equals to log x derivative is 1 upon x. Log x derivative is 1 upon x. Okay. 1 upon x. It's a special, and x should not equals to 0. X should not equals to 0. Whenever you write in the denominator, not only in the mathematics, anywhere with numerically, if you write denominator, so the denominator must not equals to 0. Okay. So next, see, this is the first principle formula. Can you see? What is the first principle formula? Remember it. Your teacher might ask. First principle formula of the differentiation or derivative is this. Can you read up? F dash x is equals to limit h tends to 0. Limit h tends to 0. That is wrong. That's wrong. It's a limit h tends to 0. F of x plus h minus f of x by h. So this is your first principle formula. It is, if you go in depth the proper definition, you will get more confused. Okay, it is just like a story conversion to numbers. If I write how we write the what is the limit formula for any epsilon greater than 0, there exists delta greater than 0, just like that. The thing will be like that. Okay, whenever so and whenever so and so, whenever so and so. Okay, so then there is a condition. So this is a more confusing for any epsilon greater than 0. There is a delta greater than 0 whenever uh, it's a limit formula actually. Okay, so it's a definition. It's a definition. It's a core basic definition. But what is this? So it is a first principle formula. So it is main application of the derivative of the limits to f dash x. F dash x is equals to limit h tends to 0, f of x plus h minus f of x by h. So you have to, your x value, f of x y is equals to 2x has been given. So you have to find f of x plus h in place of x. F of x plus h here, f of x is equals to 2x. F of x plus h is equals to 2 into x plus h. That is 2 into x plus h. 2 into x plus h. So similarly, you have to and apply the formula and simplify and then simplify and then simplify. You will get the answer. Okay. But actually, mathematically, what happening there? So it is total. This kind of formula is there. Actually, mathematically, it happens. making. Okay, actually, what is this? This is the derivative. Derivative is equals to slope of tangent. Okay, this is the f dash. The slope of tangent is nothing but your derivative. The slope of tangent is nothing but your derivative at that point, whatever the point if you take, the slope of tangent line, the slope of tangent line is f dash c, is f dash c. Okay, f dash 0 and all the cases. So there are the applications like that. Okay, so now if we take e power x, okay, see, just to give me 1 minute, I would like to change the application. Okay, so here we have our textbook, because that is not good for me. I should break the PDF and I should go to this application only, teacher, and your 569 to 417, 567 to 417, mathematics Australia, it is 11th. 367. To 417. Three 65 to 417. Because I developed it, but it is making some problem. Okay. Control P. Three 65. Come on, your output. Because no, it has been edited, so that's why I need this PDF only. Just give me 1 minute. Control P. Okay, come here. 365. So this is the case. Can you see the screen? No. You can see the screen. You can see the screen, but the live people can't see the screen. Just give me a second. Oh, so changing my screen to for the YouTube live. I think it's yours also stopped. Okay, I will reshare the screen. Still is fine. Okay. Okay, so we're back. Okay. So can you see this is the graph? So it is f dash x is equals to f dash x is equals to limit h tends to 0, f of x plus h minus f of x by h. Okay. Actually, this is, do you know what is this? This is average. It is an average. It is an average in terms of f of x plus h and f of x. Okay. So that is a formula. So where here it makes the, it's a slope. It's a slope is equals to, it's a slope is equals to f dash c at wherever the point is there. Okay. See here, it is m is equals to the slope of tangent line. We will see further deep. Okay. So what is this? A power x derivative d by dx of a power x is equals to a power x into m. M is nothing but m is gradient of its derivative of a power x at its y-intercept. Okay. It will come. It will come. Please, it is not clear to you. I know. So a power x derivative is a power x into m. And what is m? M is the gradient of y is equals to a power x. That is dy by dx. So that is dy by dx. Okay. So next, the definition of E. E is mathematical constant. Can you read these two lines? This is the base value. This is the base value where the function provides the equal log where 1 so is equals to 2.7183. It's a mathematical constant, just like pi. In mathematics, there is a e. So this is e. It is our exponential only, e power 1. That's it. Okay. E power 1. When x is equals to 1, the e value will be e. So it is e power x will be 2.7183. And this is the definition. This is the definition. E power x is called the exponential function. Is called the exponential function. And all others are also exponential only, but with base a. E power x is exponential function with base e. A power x is exponential function with base a. That is the important observation. And d by dx of e power x is equals to into m. And what is m is the gradient of y is equals to e power x at its y-intercept. Okay, at its y-intercept means e power 0 is equals to 1. M it's a gradient. Okay, it's a gradient by definition of e. So you have to understand e power x is equals to the derivative of e power x is e power x. Don't go such a depth. Okay, so just remember e power x is equals to e power x is the derivative. Clear? And next, do you know this is a graph of e power x? Yesterday we have seen in the last class. E power x, e power minus x, minus e power x, minus e power minus x. There are several graphs we have seen. Okay. And this is x plus 1. This is another line. So y is comparing. The graph if y is equals to e power x has been drawn below in the graph paper. Then the tangent has been drawn at y-intercept 0, 1. It is gradient exactly 1. It's a gradient exactly 1. Okay. So this is y-intercept. Y-intercept. It is a y-intercept. So if you make a line, tangent line, it's a gradient means it's a derivative. What is dy by dx of this function, which is x plus 1. Okay. So it's x plus 1 derivative is x derivative is 1 only. Clear? Okay. We'll see one or two problems. We'll see one or two problems. And the domain. What is the domain here? What is the domain of this function? What is the domain of e power x? Negative infinity. What is the range? Very good. Open 0 to infinite. Open 0 to infinite. There are no zeros, there are no roots. The curve always about the x-axis, it is a positive. So y equals to 0, which is x-axis is a horizontal asymptote. And x tends to minus infinite, y tends to 0. X tends to plus infinite, y tends to infinite. All these observations one can write. Okay. And dy by dx also tends to infinite. The curve has gradient 1 at its y-intercept 0, 1. Most important observation here. The curve is always increasing function. The increasing at in the increasing rate is always concave up. Okay. Gradients equals to heights. Gradient equals to height. What is the height? Height is nothing but, so this is y is equals to e power x. What is dy by dx is equals to? Again e power x. So dy by dy is equals to, which means, see what is this condition? Can you see? E power x is equals to y is equals to e power x is a function. What is the dy by dx is equals to? Dy by dx is equals to e power x only. So what is meaning? Dy by dx is equals to y or no? It means dy by dx is a gradient. Okay. So, and y is height. Do you know? Y is equals to f of x wherever you draw. So here, if this is point x comma y, so this is height. This is y. This is x. This is y. So this is said to be height. It is height. So So gradients are equals to height in the exponential function. Gradients equals to heights in the exponential functions. So that's why gradient equals to height. Is this clear or no? Okay. Gradient means y is equals to e power x. Gradient means dy by dx. And e power x derivative is e power x only. Therefore, we can conclude dy by dx is equals to y. So that is gradient is equals to height. Height means y actually is the y is the height. So at that point, if you want to get the derivative or or what is this dy by dx derivative or gradient, you have to get the height. That's it. Okay. So next, gradient equals to height. Gradient equals to height. The same concept you mentioned. E power x only. This is for only for e power x. Exercise 9a. Technology. Do you want to do this? Can you see? Let me go with explanation. Technology. The first two investigations are written in the graph paper exercises, so that the are independent of any device. The instructions are identical if graphing software is used. When using graph paper method, the diagram should first be photocopied. Okay. So you have to do two different tasks here. So what is the function? A 2 power x is 2 power x. Am I right? Okay. So what is the first part? First question. So take the diagram's tangent of the function. What is the tangent? It is 0. This is at 0. Okay. So at this point you have to draw the tangent. Clear? This is tangent line or no? So now rise and run measure dy by dx. Rise and run means average mean, average slope. Y differences upon x differences. What is the and this tangent? So what is the slope of this tangent? Okay, how can we get it? So we need rise and run means like this. You have to get it. Hmm. dy over dx. But I drawn it a very rough graph, na? So that's why I myself is getting confused how I have to plot it properly. Okay, so here this is important. And it's a slope. We know we want it's a slope. Okay, y differences upon x differences. Y differences upon x differences. Rise and run. Rise over run. So rise means it is 2.2, I think. Okay, 2.2, 2.1 only. 2.2. Sorry, 2.1 only. And this is 3 units. 2.1 by 3 is 2 by 3. Roughly, you can take 2 by 3 is your slope. Okay. So then the run should be chosen to 100 or 20 divisions. 100 or 10 or 20 divisions. I took 20 divisions. Okay. 20 by 30 by little. The count how many little divisions are in the rise. Okay. So this is run. Run I took 30. Rise I took 20. Rise I took 20. 2 is a rise. Rise means up. Run means forward. So this is run. This is rise. So these are the 20 units. 1 to 2. Can you see? 1 to 2. And these are the 30 units. Okay. 20 by 30. So similarly, draw the tangents of 4 more points of the curve -2, -1, 1, 2. You have to plot this graph. Okay, it is a prop. Be carefully you have to do. It is, and again there is this, and again it is around 1. Where is 1? This is 1 at 1. Are you understanding what I'm doing? At 2. So he asked to plot the slopes, tangents at -2, -1, 1, 2. Measure the gradient dy by dx for those lines also. Which scale you have to do? Take a graph paper and draw the tangent lines, then evaluate their slopes. Copy and complete the table of values to right. The values only given in the rough. See, at a y equals to -2. What is 2 power x derivative is? Y is equals to 2 power x. 2 power x derivatives, do you know y dash or dy by dx is equals to? Okay, it is 2 power x into log 2. It is y into log 2. Okay, this is log 2 into y. Log 2 dy by dx is equals to log 2 into y. Log base e, not 2, not any other. Okay, previously e power x is there now. So its derivative is e power x into log e base e. Then only it is 1. So that's why we're writing directly e power x, which is equals to y. Here dy by dx is not directly y. It's a log 2 times of y. It is a log 2 times of y. Is it clear? So next, again it's the same graph. You have to do the everything, but it is e power x. E power x. Try to get it. Try to get this problem. Try to understand. It is for your assignment today. Okay. Try to complete this yourself. Only for this particular problem, you have bunch of questions set to do up to e. Whatever you understand, then write down on a pen paper. Okay. Next, photocopy the same thing e power x in question 2, but he is asking different points. Approximately e to many significant features is beyond the score. The argument below, however, at least shows very quickly that number e lies between 2 and 4. We have to show that. We have to show that e lies between 2 and 4. E lies between 2 and 4. Y is equals to 2 power x and y is equals to 4 power x. On each graph, the tangent at the y-intercept is 0, 1. Approximating E, means it lies between 0 and 2, 0 and 2. 0, 2 and 4. It lies between 2 and 4. The argument below, however, is at least shows very quickly the number lies between 2 and 4. So here are the tables. So this is 2 power x and this is 4 power x. Okay. Is it clear? One is 2 power x and one is 4 power x. On each graph, the tangent at the y-intercept a of 0, 1 has been drawn. So in this case, they are the tangent lines. They drawn these tangent lines. Okay, they drawn these two tangent lines. In the first diagram, can you read the first question of first point? AI. This is the chord AB. What is the gradient? Now, chord AB. Y differences upon X differences. What is the point here? It's a 0, comma 1. What is the point B? 1, comma 2. Gradient is equals to differences of y by x differences. 2 minus 1 by 1 minus 0 is equals to 1. Okay? 2 minus 1 by 1 minus 0. That is a gradient. Slope of the tangent line also it is the same. And hence explain why the tangent A has a gradient less than 1. Gradient less than 1. At A. At A, the gradient is less than 1. In the second diagram, find the gradient of chord CA. Hence explain why the tangent A has gradient greater than 1. Oh, and use these results to explain 2 less than E less than 4. 2 less than E less than 4. Use these two results too. Okay, we will use that result. Gradient means is the only thing. Find the gradient of chord CA. Here it is minus 1 by 2 comma minus 1 by 2 minus 1 by 2 comma 1 by 2. And what about grad of CA is equals to? This is 0 comma 1. Okay, it is 1 minus 1 by 2 by 0 minus of minus plus 1 by 2. It is equals to 1 by 2 by 1 by 2 is equals to 1. Okay, but less than 1 greater than 1, how we have to define? How we have to define how it is less than 1, how it is greater than 1. The gradient has less than 1, the gradient has greater than 1. Okay, I will explain. These two are most important. Okay, most important. Why they are less than greater than? I will check and I will come to this topic later. Okay, one or two problems are missing, but I will explain. Don't worry. Is it clear? One or two questions are missing. Don't worry. So next is the question requiring the graphing software. So using MATLAB or that is Desmos only we can do. Okay, let's go a little bit technology again software. Okay. So up to challenge only 6 problems. So keep exercise 1 as it is with the rest of the remaining problems. I will come and I will explain. Only 2-3 problems are left. It is not completed. Okay. Next, can you read the heading of 9b? Exponential function has to be transformed to another. Okay. So that is e power x, e power minus x, e power 1 by x. Okay, 1 by e power minus 1. It is root e power x. They are the basic things we already seen. E power x plus 3, e power minus x, e power x minus 2. Accordingly, the values will be different. The approximation, the graphs will be different. The slopes will be slope could be same. Slopes could be same. The graph approximation values are different. Okay. Now exercise technology. The transformations of the graph of exponential function y is equals to x in question 4 to 7 and 9 and procedure question 8 can be performed using graphing software. Experimentation with further graphs can be done. Use the button labeled e power x in your calculator to following correct up to 4 decimal places. Do you have the calculator? No need. Right now it's not required. Do you have the scientific calculator? So there will be E. So apply and try to get the answers. Okay. Apply and try to get the all answers. And each expression has power of e. So as power of e. So what is 1 by e? How can we write as a power of e? E power minus 1. What about the next one? Next one, f. Minus half because over this. What about this? Power 1 by e to the power of 1 by 2. So write using power of e, approximate the correct significance of the four values. So you have to evaluate the values simply using calculators, try to get the answers. It's the graph of y equals to e power x, then use the graph knowledge of transformation. Can you read this question? Take the domain and range and asymptote. Okay, each and everything. What is this? What it means? How can you say it's a graph? Will dance. E power x moves to up one. Okay. Second one, 1 unit up. Here it is 2 units up. Third one, down 1 unit. Fourth one, down 2 units. Okay. Copy and complete the following tables using give the 4 decimals. It's a 1 by e square. Okay. 1 by e 0 e square. Sketch both graphs on the number plane and draw the tangents at each of y-intercept. Go to the y-intercept and plot the tangent lines. What transformation exchanges these graphs? What transformation exchanges these graphs? E power x, e power minus x. This is part 5. This is part 5. Again, you need the software only. You have to use the software. That is Desmos. You have to use the Desmos and try to get the answers. So go sketch the transformation exchanges. That is 1 upon x. One is e power x. Another one is 1 upon e power x. So this is the transformation. And I saw the tangent of the e power x y intersect has a gradient 1. What is the gradient of its minus 1? What is the gradient of e power minus x? Okay. E power minus x, its gradient is, its derivative is minus e power minus x. Okay. So the gradient of at y intercept is minus 1. This is minus 1. Okay. Explain why two tangents are perpendicular. Because their grade product of their gradient is minus 1. I should come to here. I should come to here. We have to take the graph extension. E power x in e power minus x, you have to take the graphs. What is how the e power x graph look like? How the e power x graph look like? The e power x is like this. Okay. So this is the graph. What is this? This is your e power x. Okay. What is e power minus x? This is e power minus x. This is e power x. Okay. Yeah. Now I'm drawing the tangent. So for e power x on x-intercept, this is its tangent. Okay, this is, and its tangent is like this. And do you know this makes 90 degrees because its gradient is equals to 1. Its gradient is equals to 1. And its gradient is equals to minus 1. Its gradient is equals to minus 1. So this is the case. Okay. So you have to get this understanding about it is extended calculus. That's why it is a little bit advanced only. So we have to. I will repeat. I will repeat all these problems once again if it is required. Okay, for more clear understanding. Sixth one. E power x y equals to e power x. What is the horizontal asymptote? What is the e power x graph in the previous image? This is the left one. So is there any asymptote for this e power minus x? I'm drawing the sketch again. E power minus x. So this is a graph of e power minus x. Okay. So these are the lines. E power x graph is this. Clear? Is there any horizontal asymptote? X-axis. That is y is equals to 0. It is horizontal asymptote. Horizontal asymptote. No vertical asymptote. That's it. Okay. No vertical asymptote. Use the knowledge. This is the knowledge of your transformation. So what is the graph is moves up or left or down or right? E power minus x plus 1 gets up 1 unit, up 2 units, down 1 unit, down 2 units. Next. Now this is, please tell me the seventh one. Use your knowledge of transformation. So, so we have to plot this one of the graph here. Okay. So what is e power x? This is e power x. This is e power x. What is another e power x minus 1 graph? How it look like? On x-axis, what is the graph? No, no. One is e power x and one is e power x minus 1. F of x, f of x minus moves to the right. Okay. If this is 1, now here it is 0, it is 1. Okay. So it is moves to the right. 1 unit right. Okay. 1 unit moves to the right. Moves 1 unit right. So what about this? Moves 3 units. 3 units right. What about this? E power x plus 1 moves to the left 1 unit. Left 1 unit. It is a left 2 units. Okay. Next. A, B, C, D. A, B, C, D are the points of e power x of coordinates 0, 1, 2, 3. with x coordinates 0, 1, 2, 3. So you have to understand it. So this is a graph of e power x. This is a graph of e power x. This is e power x. 0, 1, 2, 3. E power 0, this is 1 point, another point, another point, another point. Okay, is it clear? So this is e power 0, 1. It is e power 2, the e power 3. Okay, e power, this is this is e power 2, and this is at e power 3. So find the y coordinates a, b, c, d and sketch the situation. I drawn. Find the gradient of the chord a, b. This is a, b, c, d. We have to plot like this. Okay, it is like it goes to like this, and the chord will be like this. So now, please tell me. Hence, use y minus y1 is equals to min x minus x1 to write the chord of the equation. So this is 1 comma e. So what is this point a? What is the point a? 0, 1, right? Thank you. E power 2, e power 0 comma 1, 0 comma 1. So you have to get this equation. Okay, you have to get the equation. But what is the slope? Slope is differences. Differences is nothing but e minus 1 by 1. Okay, y differences e minus 1 by 1 minus 0. It is a slope. Put y is equals to 0 and I show that the x-intercept. What is the equation? What the equation is, you have to write down the equation. You have to write down the equation y minus 1 is equals to x1 y1 x2 y2 y minus 1 is equals to m e minus 1 by 1 into x minus 0 is equals to is equals to is equals to y minus 1 is equal, implies y minus 1 is equals to x into e minus 1. What is the second function? Put y is equals to 0 to show the x-intercept. X-intercept is this. So here when y is equals to 0, what happens? Minus 1 is equals to x into e minus 1. Implies x is equals to minus 1 by e minus 1. Minus 1 by e minus 1. Minus 1 by e minus 1. Okay. Repeat the procedure with the chord BC, chord CD, chord this. Everything is same. You have to, the points will be changed. So what is the C point? C point is 2 comma e power 2. D point is 3 comma e power 3. Okay. So we have to repeat the same process C and D. Is this clear? Okay. Just take a little bit break. Okay. And then after that we'll go with the ninth and onwards. Should we continue in the next class? Okay. So just 10 minutes break. Then after that I will continue the next class about the ninth. And A, B will be complete. We will start. I will explain the C part today. Okay. So here I'm ending my live session. We'll back in 10 minutes. Okay.